Hi, everybody. So my name is Jose Luis Peralta. I'm a CTO of GIM Robotics.
Hi, everyone. I'm Lorenzo Nava, former CPO of Inxpect, so Chief Product Officer. I recently moved into a new role with Reynolds & Moore, and happy to be here.
So we have the difficult slot of after lunch. So our goal is here not to get you guys sleep, and to help a little bit as well. I chose this. That's my fault. No. But let's get started with like simple message, what we're gonna try to show in this presentation. So it's not like a mystery. So it's a spoiler alert. First thing is that automation is already ready for outdoors. So all the things that you need to make an AGV, localization, perception, is possible to do outdoors. Then the second part is safety as well. It's possible to do outdoors. And we have done that with Inxpect. And here is like our experience with it, how we have solved it and how we propose to support also other ones that want to take that journey. Spoiler done. Here's our background. GIM Robotics, we have been in the mobile work machine from the research from the mid-'80s. We've spin off the company in 2014, so over 12 years, where we have been then supporting different mobile work machine manufacturers that being in forestry, in agriculture, in construction, and later on we also are in logistics. We started from outdoors because we had a competitive advantage of having your navigation and perception optimized for outdoors. It was a bit more expensive, but now we also going for logistics, starting for outdoors as well, but also indoors now that the sensors and everything had catch up with the needs. What we offer is standardized software modules that can be used to develop your own AGV or mobile work machine. This is the part to get you guys awakened. Videos. So what do? We help companies like this. This was a street sweeper company that previously needed to have a wheel loader behind it. They wanted to do completely autonomous solution. So we provide them with the perception that they need for navigation, so positioning, but also obstacle detection, low-level control, control of the machine, and even support for integrating different components like the battery management system and so power supply and so on and so on. So this was a full stack development for them. Here we also encounter Inxpect whenever they needed to do the safety here, following the ISO standards. But we have been long time in different applications. This is not a simulation. This is just a company that we cannot say the name about it. It's the digital twin. Here we are doing driving assistance solution for tractors. We provide solutions for forestry machine, where we localize in the dense forest, count trees, measure the size of the trees. We have been working also in maritime application, localizing based with radars or LiDARs for both obstacle detection and avoidance and captain assistance or berthing of the ship. We have done construction as well. Here as well, difficult is not just driving assistant, but some parts are completely autonomous for the different cycles that the machine needs to do operational. As you can see, there is potential challenges for safety here. You are interacting with the environment. You want to push things around. You need to be able to discern of how can we do this safe. But yeah, snow cleaning, that's something that we do a lot in Finland. So good to automate. It's becoming a bit long, so I go forward. After that background in that industry, even have trams. I let the tram go. So obstacle detection for trams as well. Not fully autonomous trams, but driving assistance. So then the safety again is part of the drivers. This is the way it starts with difficult industries. So you start with driving assistance because it makes the application more efficient. And then you slowly go towards automating the parts that you think that you can do it safely. At the moment, this is actually now going towards autonomous stopping the tram, but it's a process that we had to go with Skoda trams to get it properly certified for it. Now, logistics. More and more, we have been able to deploy these solutions as well. And outdoors logistics, what we're talking here. So most of the applications have been tuggers, but we have also some flatbeds and starting to do also forklifts. There are different applications and the different levels of speeds that these machines need to have. And that's where we encounter the first challenges, to how we can make this certified for safety certified machine and be able to operate. There are different working conditions that the machine have. It can work in mixed environment, so with manual drivers. It can be that there is people. We don't go in public roads yet, but yeah, that's what we're going to discuss today.
Yeah. So who is Inxpect? Let's present a little bit. Inxpect is a company that was founded in 2016, so it's 10 years old. In Italy, based in Italy, with a few subsidiary and distributors all around the world. It grew a lot in the past 10 years, now having more than 10,000 systems installed and running in plants or applications all around the world. And Inxpect managed to put together a team of experts in the radar domain. They have basically experts that can cover from the hardware design up to the software design and applications, so that they have designed and then certified the first safety radar for industrial applications. Now it's a mature company, as said, serving clients all around the world, starting from industrial automation, mainly indoor, then moving to other application, moving applications, and also, of course, outdoor environment where the radar, as we will see in the upcoming slide, can guarantee more robustness with respect to, in general, environmental condition where it can operate. We skipped some slides. Now we go back. Yeah, I'm done with that. Yeah. Okay, thanks. Okay. So let's start to talk a little bit more about safety. We will then expand that in the second section of the presentation. So our idea and working together with GIM, this was actually something that was really evident, that when you have to design a new mobile vehicle, the important thing is that you consider safety since the beginning. So what we experience is that typically, especially if we look at the indoor applications, the solutions are more mature there. Even the safety, to some extent, is simpler to achieve because of the general conditions where the sensor needs to operate. And for example, in forklifts, a common solution is to use laser scanners for safety, together with other sensors that, of course, can cover more the automation part. But when it comes to outdoor, the requirements are much more challenging. So if you want to reach the safety compliance and be able to operate with a certain degree of availability, meaning that you don't want to stop because of false alarm every now and then, it's important that you include the safety design since the beginning. So safety design should be alongside with the automation design of the vehicle.
Yeah, so on our perspective was that we were provider of automation technology. So we're the navigation. And the idea is that we provide that the automation, but the safety is on the OEM. and there was always this available solution for the safety, and indoor it was the plug-in safety lidars. We do not have that parallel in outdoors. It's not something that they can start at the end of the project that they build, okay, let's plug these sensors, and it makes it safe for outdoors. It's really a process, as Lorenzo says. And how to better do that process is part of the learning here.
And let's go ahead. So what are the 3 important steps when it comes to understand how you can include and add the safety into your design? So first of all, and we're gonna take a, let's say, deeper look at those points later on in the presentation, but first of all, ODD, so Operational Design Domain. It's important to understand where you're gonna operate. How is your environment? But we're gonna look into that, but it's the first important step. Understand where the application is going to be deployed. Second, HARA, so hazard analysis. You need to understand the risks. The risks are not only, let's say, risks connected to people, so harming people, but it could also be other type of risks. Could be, for example, I guess we'll see that later, but batteries, the analysis of risk connected to batteries and in general to power supply includes a lot of potential risk in general for the application and for people, of course. And then, as said, safety needs to be part of the design. It cannot be an add-on. It needs to be considered since the beginning.
And then how do we usually do this is that, again, we try to take care of these specific parts of the solution that we are building, but that is unavoidably an interaction that we have to have between each other. Some of the sensors might be also used for the application of the safety, so we need to understand each other since the beginning that here's where we need to place certain sensors in order to be able to operate safely on the obstacle detection, on communication with the infrastructure. And this needs to be also be reminded by the safety provider that, okay, this will work if there is this inclination of slope, or we're gonna have problem with slope, we need to reduce before we get to the slopes and things like that. Some cases we even have like negative obstacles outside, so you can approach a place where you can actually fall, and those are difficult to detect with other standard sensors. So these as well can happen with the radar. So we need to have all of that in consideration. In some applications, you cannot have just one source of positioning. You need to have redundant sorts of positioning, and those need to come into the controller, certified controller, which also needs to be used by the other sensors. So again, not just an add-on, but it is decisions that need to be taken since the beginning for that process.
And yeah, on the Inxpect safety side, I think the radar technology has brought really a great advantage, especially for outdoor applications. Outdoor, when it comes to optics, there are several conditions where optical sensor may fail or may reduce the capability of detection, because typically if you think about fog or snow or heavy rain, those are conditions that typically affect the capability of detection of optical devices. So Inxpect introduces the first, as I said, certified radar for industrial applications, and the radar capabilities are the one that you see in this slide. So it can be very robust to environmental condition. It can work, operate safely in raining conditions, snowy condition, up to 45 millimeters per hour. And we also at Inxpect designed extended range capabilities. So we know that sometimes, especially for outdoor vehicles, speed is not limited to 2 meters per second, which is the typically maximum speed of indoor vehicles. Outdoor, you can travel much faster. You can reach 4 meters per second and above, because there are applications that can easily reach even 30 kilometers per hour. And to try to help and support also higher speed, the radar was certified to actually cover 9 meters range safety detection, and which is at the moment, I think, the maximum length in terms of detection field, that safety detection field that a sensor can provide, and a maximum speed of 4 meters per second, which is about 15 kilometers per hour.
Yes, and again, from the perspective of design, what that helps is that can reduce the amount of components that we need there. So in some cases where the speed is not that fast, we can even maybe use bumpers, when this Tugger was mostly on crawling speed, transporting very heavy components from one warehouse to the other warehouse. But even in this design, we needed to use two 3D LiDARs plus the bumper in order to reduce enough the speed in time, and all of that through the safety controller. With the LiDARs are considerably more expensive than the radars, so that's something that we learn during this development stage, once we know that we can use the Inxpect radar, so that was the preferred option there. But yeah, there are different applications and solutions that you can come up depending on the conditions here. As Lorenzo says, everything depends on the ODD, operation design domain. The safest AGV would be an AGV that doesn't move or move very slowly, but that's not productive in many applications. So if there is rain, if there is fog, it should continue working, and it has very, very downtime or very, very reduction of the speed of the machine. And that's what we were able to achieve with the radars from Inxpect. Did I jump on? Yeah. Another application was in indoor logistics as well. Here, we were able to use radars mostly for outdoors, and indoors we still had the safety LiDARs. The speeds were varying, and we have different zones, what's indoors and what is outdoors, and there is level of safety requirements from different zones of the environment. Yeah, so this one of the first integrations what we got within Inxpect radars, and we're able to manage chaotic places where there was a lot of dynamics, also with this combination of sensors.
Similar application, tow tractors. Here is application more for logistics in airports, but also factory logistics. This is, as you can see, we start seeing how many sensors you actually have to use when you have to deal with outdoor applications. So here we highlighted a little bit the combination of different sensing technologies and different sensors that are used to actually being able to ensure the performance and the safety of this kind of vehicle. And so you see LiDAR, both, I think there was a safety LiDAR and a non-safety LiDAR, then safety sensor, radar sensors, cameras, and other type of LiDAR. I didn't mention, but I think another relevant aspect, radar is natively 3D technology. When it comes to navigation outdoors, sometimes even having the capability of perceiving the environment in a 3D space, it's much more, it's an advantage compared to a 2D detection. And the challenge is sometimes is also that when you're navigating even in a very open environment, you don't have a lot of references. So when it comes to positioning and navigation, so more for the automation, it's sometimes a challenge. You can do that with GPS, GNSS, but again, it's part of the operational design domain that you have to consider. Another type of application, different domain, sweepers. You saw the video previously of this kind of application. Challenges here, of course, as you can guess, it's dirt. So when sweepers work, they just generate a lot of dust. And the perfect solution was the Inxpect radar that can just simply go through the dust and detect the object easily. So that was very convenient. As you can see, the radar placed also pretty close to the sweepers. So it is really impossible for optical devices to actually guarantee the safety in that kind of application.
Yeah, and then from our side, for the navigation, the dust is not ideal, but it's not a problem for localizing the machine. But if you're trying to detect if something is in front or not, you cannot just ignore based on intensity, which is usually what we do with the lidars. So you needed to have like a second layer of information, which is the radar for the safety. And yeah.
Okay, let's go. As I said, we're going to go through the different stages that we briefly talked about previously. And starting from the ODD.
Yeah. Yeah. So what we want to get here is kind of facilitate the life of the new OEM that wants to take these challenges for outdoors. So kind of this is the roadmap that we propose, and then we actually have like specific work packages that we have developed together as an offering to get through those without having the OEM to do this kind of a journey by themselves. So the first thing is that you need to have a clear specifications of your operating design domain. You need to really inquire with the OEM that's trying to develop a new solution for outdoors, where it needs to operate and what's the level of performance that needs to achieve on that environment. The speed, the environmental conditions, the physical environments, so it's the road, the slopes, how much unevenness of the terrain, how much shakiness, all of that needs to be very well specified. Something that sometimes is not very used to do, at least in indoor logistics, because it's quite matured. Everybody knows that if you put one sensor certain centimeters from the ground, you're over with most of the safety. But this is not the case in outdoors. You can see the ground. You can stop because of the rain. You can stop because of the fog. So you can stop because of vibration. So all of that needs to be very clear. And if you're going to reduce the speed in order to be able to be safe, you need to be in agreement beforehand that that's allowed by the performance. So then your client at the end say, oh, but this is slowing all the time. It's very safe, but it's not producing what I need to produce. So this really needs to be very well specified.
Next slide.
So.
This was pretty much what Jose was going through. So, and you have different aspects to consider. So again, it goes from even mechanical robustness. If you consider the indoor environment, you typically have flat floor, and but if you start to go outdoor, you can have uneven terrain where you're traveling that can cause a lot of vibrations, can cause pretty hard shock. So even mechanical constraints sometimes are a problem when it comes to select the range and the type of sensors that you want to use in your design. Temperature as well sometimes is an issue. If you're going to operate in below zero temperature environment, you can have, for example, moisture on the sensor, and that could affect detection. So there are several different aspects that you have to take into consideration. And when it comes to outdoor applications, those combinations are even higher or even more. And it's not always easy to find the right trade-off and the right balance between the performance that you really want to achieve and the safety and, in general, the kind of tasks that you can do. Yeah, now the slide that everybody was waiting for, the boring safety slide with a lot of standards that I have the pleasure to present. So when it comes to hazard analysis, of course, today we have, as you know, a standard that is one probably most important reference standard that most of the autonomous vehicle manufacturer is using today. Is ISO 3691-4, which was recently even harmonized, and now they're ready to go through a revision. They're creating new groups, creating new standards, so the complexity is growing there. But 3691-4 actually was born for forklifts, so the title of 3691-4 is industrial trucks. Industrial trucks translates into forklift, basically, so requirements of that standard go pretty much in the direction of for automated forklift. But then it turns out that now that standard is no longer sufficient to cover all the different type of applications, talking about vehicles, that we have in the industrial field. So other standards were then generated in the agriculture, in the construction, you name it. But not always it's easy to navigate through the complexity of standard and which standard should I use, how I can combine them.
For me, it's not easy. That's why we used to.
Yeah. That's why I'm here to kind of talk on how easy it could be.
Yeah, but it's right. Sometimes we even have to encounter a bit the automotive standard, because there was an application where we had to do transport of people. So it was a shuttle inside a closed environment. So then we have to do the ISO 26262. Plus, then there is another ISO which is specifically for that is 22737, so a low-speed autonomous vehicles. So it's coming, as Lorenzo says, you need to know how to navigate that. And in order to learn it, so it's better to have with an expert together with you. The one that already has passed to this, know the standards, and can tell you, okay, if your machine does a bit of this activity, maybe we can put it into construction, if it's cleaning the yard, or if it's actually moving, which is most of the time moving material from A to B, then the industrial trucks should be the one you use.
And the idea is exactly, how can I save time during my design phase, just pick the right standards that can help me to design the right and proper architecture to achieve the goal that I need to achieve. Just to mention one additional standard that is not a lot of people know, but it's the 62998 is becoming international standard soon, and it talks a little bit about how you can combine sensing technologies into a system to achieve safety, or how you can extend the capabilities of some sensors so that they can be certified for safety for your specific use case. Again, sometimes it's just pick and choose, so you need to go through all the standards, select the parts that apply to your application, and that's why this process is important to have somebody supporting that, and at the same time also doing that since the beginning, as we said.
Yes. Here's an example.
Yeah. You want to start?
Yeah, you can go.
I'll start. And when it comes to implementation of the design, we choose the Trombia use case just to show how in this application the solution was eventually achieved. So as you can see, we have a combination of 3D non-safety lead LiDAR and the camera for perception data. And for safety, we have two radars on the front and on the side that are guaranteeing basically that the machinery will not collide with people. The combination, as you can see, the architecture is pretty complex, and there are two domains we're going to see in the next slide, and the interaction between the two domains is not always so straightforward.
Yeah, so we do have the automation or the perception domain, which we need for navigation, which we do with 3D LiDARs that allow us to have positioning, localization of the machine and the environment, plus is also detecting around the machine. We can do things with that, kind of detect potential obstacles that come, but in order to be safe, we cannot use that because the laser is not safety certified. So we need to include either redundancy on the detection and go them by the safety controller, or we can use alternatives of reducing the speed into a certain level to then reach the safety barrier with the radars with the proper speed. Yeah.
So yeah, I guess now the question that all the AGV manufacturer have is like, why so many sensors, and why I should have one domain that is not talking to the other domain, or can just talk in a very limited way to the other domain. And so, good question, and I think everybody's looking for a good answer as well. And I think if we move to the next slide, one idea that I guess more and more we're going to see, and I hope we're going to see, is sensors that can provide both data and safety signals, so that with a single technology and a single sensor, you can actually cover or better use the same sensor for the two domains that we saw previously, so the automation domain and the safety domain. Probably one technology will never be enough when we're talking about outdoor, because the environment is really complex, so it's really hard that with one sensor technology you can really deal with all the different scenarios and possibilities that you have to cope with. But at the end of the day, the goal is how we can optimize the platform, how we can have more sensor maybe able to support both the navigation and automation part and the safety part. That will lead to simpler architecture, and of course will be a significant also cost-effective solution when it comes to bill of material.
Yeah, so the parallel for the indoor case will be that you can do navigation with a safety laser. And now is actually coming 3D safety laser, so you can do navigation and safety. For outdoors, that's complex. We don't have a safety laser that we could use for navigation outdoors. At least the safety lasers that are there, yeah, we need 3D. I think there is just one 2D. And the radars, the problem at the moment is it doesn't have enough accuracy on the ranging measurements or even the amount of points that we need for the accuracy of navigation. But what we see more and more is that, yes, the technology of the radars are evolving, both on the ranging and the amount of the point clouds, that I see a path towards that we could use in the future, both radars for navigation and safety. And that's kind of the discussion we're having in the future with Inxpect. Then, this is the slide with many words. What's the proposed solution here? So what we want to simplify the life for somebody that's brave enough to try to get some AGVs or AMR going outdoors. So the idea is to have a containerized package, or you know how much you're going to spend for different stages of the process. So you don't start with something that will take forever. So we try to divide this into packages that we can help you out through the process. The first one will be to do the risk analysis. So you get a consulting package from Inxpect and kind of help you design, help you navigate with the ODD and help you support or choose what's the correct standard for your application. Then the bill of material, which is part of the discussion with architecture, also with us, with the navigation. So we then understand what are the requirements for the safety, and we also propose a hardware bill of materials. And then integration, the idea is that you don't do developments, but you integrate ready-made solutions. So if you have a positioning system, you have as you have indoors, you have a navigation software, you have a fleet management software, and you have the safety where you need to program your zones. And that's, again, standardized, and you know how long it takes, and you have the training for how to use it yourself. You don't want to have the experts forever in your production. This is something that you need to do once and then have the training for it. And yeah, the validation is kind of the support of the experts through the process of validating your product to be safety certified. And that's one of the products that can provide us one.
Let me say that in my experience, especially with new technologies and new solution, And so many times the risk analysis to be here, okay? And this is just like doubling, making 3 times higher the cost of the overall design, because you just come to the end and then you say, okay, great, now I'm not complying with anything, and you start over. And you need to review the design, and you need to review a lot of stuff. So that's why, I mean, this is really important. You start. At the beginning, everybody will say, oh, safety, it's a cost. Yeah, but that makes save money at the end of the process, and especially makes, at the end of the day, the time to market much faster than if you do that at the end of the process.
And at the end, this is kind of accumulation of experience through the process. So we have done projects before, and we know what packages of hardware, standard hardware, already work in certain conditions. So it's easy for us to also recommend, okay, buy this, this, and that, and you get this solved. So it's not something that we want you to start also from scratch. Whatever we can get as a compact package that we know that it works in certain conditions, we will propose it again and reuse it. That's what. And that's it. Thank you very much.
Hello. Echo, questions. Is someone developing outdoor mobile robots? Some question? No? Here, there. Okay, good. Please present yourself.
Yeah, my name is Sam Herbots from Mabo Engineering and Automation in Belgium. One question for Inxpect, maybe. How many different safety fields can you configure with your radar system?
Sorry, say that again. The different?
You probably define safety fields for the radar detection. How many can you define into the software?
So it's up to 4 detection field that you can let's say, configure in terms of shape for one configuration, and you can have up to 32 different configurations. So it's a combination of up to 4 detection fields, safety detection fields, and 32 dynamic configuration. The dynamic configuration should be set in advance, so you have to define a preset of whatever number of configuration you need, which is pretty common in application because you have to go straight, steer, slow down, and so on and so forth. Then you have safety input signal or safety field bus that you can use to change dynamically the configuration with zero latency time, so they can be changed in real time without delaying any detection. And that's it.
Some more questions? I have one question. Mark, okay. Please, Mark, first.
Yeah, Mark de Groot from JBT. We have outdoor vehicles, and I'm wondering what your temperature range is with a radar sensor.
Radar goes from -30, so 30, -30, to +60. So pretty broad range.
It's interesting also for cold storage.
Yeah.
This is why, no? I know you. Now, I have one question, because before we saw a tow tractor, you said that you had implemented the safety scanner and the safety radar, no? Do you switch between one or the other depending on the positioning of the vehicle? How do you, because I tell you, because if we go, for example, indoor, maybe we use the safety typical LiDAR, okay? Yeah. And then when you go outdoor, you will use more the radar, which is more reliable in terms of weather, okay? So are you doing this switch of fields between the LiDAR and the radar?
That was done during the development process, so have it as an alternative. And at the end, what we realized was that with the radar, we can actually both cover the indoor and outdoor. So it was a bit redundant in that sense. We thought exactly the same. So we identified the zones in a safe way when we are indoor and when we are outdoor, and switch between those, which kind of adds complexity in the safety controller, because you need to have a safety way to know
This was my next question. I wanted to pick you.
Yeah, but
how do you know you are in a given point to switch safely?
Again, there is communication with the door, and it was a complex architecture.
Okay.
And the best way was just to simplify the case, and we were able to just do it with the radar.
Good. Some more questions? Someone else? Okay. No. Thank you, guys. Thank you. Okay. Good.